Hi, my name is Kyle Betts, and for my ECE 3140 final project, I created the old game Simon. So for those unfamiliar with the game, how it works is the computer will show a pattern on the LEDs, and then the player's task is to recreate that pattern by pressing the buttons. Now each time the player correctly repeats the pattern will increment by one new light, and the player will have to recreate that pattern. And then this just continues on until the player makes a mistake, and at which point their score will be the amount of patterns they correctly repeated. So when I plug my game in, it brings up the start menu. So the buzzer plays the song from the original Mario Bros. And then the LCD screen gives you a prompt to play now and also shows the current high score. So when the player is ready to play, they can just press any button, and then the pattern will begin. So the pattern is created by randomly picking a number between 1 and 4, with 1 being red, up to 4 being yellow. Now you'll notice that each time I get a level correct, the green correct LED lights up, and the buzzer plays a fun little song telling me that I got the level right, and also my score continues to increment. Now say I make a mistake and I press yellow here, all the LEDs will light up and a sad song will play, and the LCD will inform me that my game is now over. Now also, since this is the first game I've played, this will be a new high score, so the buzzer plays a fun little song and the LCD informs me that I've achieved the high score. So it brings us back to the start menu where the buzzer plays Mario again, and now the high score has been updated to the one I just achieved. So I guess I'll talk a little bit about how it works. Basically, I use each different state in the game, such as initialization, the start menu, the showing of a pattern, and the player's input to repeat that pattern, are all different states. And each state is represented as its own process. And then I use a priority-based scheduler where the process whose state is the current state has the highest priority, and therefore will get to be scheduled. And then every time a context switch occurs, if the state hasn't changed, then the process that was just running will get to keep running because priority wouldn't have changed. But in the case that the current state has changed from the last time a process was scheduled, then all the processes will have their priority reordered, where the new process, which has the current state, will have the highest priority, and then we'll get to operate next. So that's how I move between the different states in the game. Also, I use a linked list, similar to how we represent the queues in the labs, to represent the pattern. So I create a struct which has an LED and also the next LED after it. And then to increase the pattern, I simply just append a new one of those structs to the end of the current pattern. And that makes it very easy for moving between the pattern and showing it. Now another feature of the game is that if the player is inactive for a certain amount of time, then it'll time out and the game will be over, which I'll demonstrate here quickly too. So say I press the blue, but I don't press the yellow for 10 seconds, then my game will end. Like so. So the reason I put this in is just so that if a player stops playing mid-game, it doesn't make my game get stuck. And also you will have noticed that since I didn't set the high score, I didn't get the fun little message, and the high score remains as 4. So that's about it for my demo. I hope you enjoyed.